That's step one. Step two for today, I want to once and for all put the Biot-Savart law in a table for your reference for quick check of what it would look like. Okay, so that's step two. So here, I want you to write number one, magnetic field of a steady line current at R is written as B as a function of R, mu 0 over 4 pi I times R over R squared dl integration. Where mu naught is 4 pi times 10 to the minus 7 newtons per ampere square. By the way, did I ever mention what the units for B are? Units of B are Tesla. And 1 Tesla equals 1 Newton per ampere meter. This is what you have seen in intro 1. However, here we expanded the current from a steady line current to even flowing over a surface. When the magnetic field flows over a surface, exactly the same as we have above, but instead of I, what will we be using? And instead of dl, do you see how the progression happened? For surface currents, I becomes K, dl becomes the small area over which it flows. Now, what do you think the third one will be? So we talked about a line and then a surface. Third one is volume. Good job. Number 3. So magnetic field due to volume current. Anyone remember the symbol? IKN, it was the last one was J, right? So for this, it'll be exactly the same. J cross R. And instead of dA, it will be over, CJ, what would you like to call it? V or tau?
V.
Okay, V it is. Do you see how pretty this looks? It's all in one page. You can see it all at once. I like this. Oh, another thing I want you to add, if you can here, remember this, that this law does not hold for point charges. Remember we talked about it. Point charges do not make a current. So Biot-Savart law will not hold for point charges. 1 point charge will not make a current. Another thing that I want you to know is what is called the principle of superposition. What is this principle of superposition? Do you remember when we do forces, we write that if there are more than one force acting on something, we write it like this? B fields are exactly the same. So when you have multiple B fields acting on a single point, what you're supposed to do is you're supposed to write sigma B equal B1 plus B2 plus B3 . In other words, the total magnetic field due to a collection of source currents is the vector sum of each field added together.